Most AI security tools promise to assess your environment, but can they actually reason about the risk? In this video, I'm going to take a realistic Databricks-based data platform, run it through the Bayesian security engine that we've been building over the course of this series, and see whether the results actually make sense or not. And more importantly, I'll show you where this approach helps and where it still has some limitations. A quick recap first. So we have controls, we have expert knowledge, we have Bayesian networks and incident likelihood, and something new that I added, the business impact. Basically, it is a similar third layer of the Bayesian network on top of two of the existing ones. So the experts will generate the risks. From the risks, we are going to generate the incident likelihood, and from the incident likelihood, we can generate how those incidents potentially would impact their business and what is the likelihood of different type of business impacts. So pretty much everything as it was before, just one more level of abstraction, and you can check the code on GitHub as usual. And with that, I want to introduce Cut Me Own Retail, a medium-sized retailer with about 300 employees. It has online sales and on top of that, physical stores across the country some country. And they have a modern cloud analytics platform based on Databricks. For this one, everything is controlled through Azure Entra ID. So all of the service accounts are created over there. The users are created in Entra ID, and they assigned separate groups. Then, based on the groups, they have access to Databricks. From Databricks, we have obviously the Unity catalog, and all of the data that is required is exported into their storage. And from that storage, the Azure Data Factory reads it and generates the data in a medallion architecture for the Power BI reports. And those reports are consumed by business users to check what is the churn rate of their customers, what is their most profitable items that they want to restock, and what are the issues with stock in general. And in terms of the current security posture, it is a mix like in all real companies. And we have some good things like multi-factor authentication is enabled, we have the private networking, the Unity catalog itself plays a big role in terms of their governance, we have cluster policies in place and central login as well, and encryption at rest and in transit, everything is implemented. But at the same time, as I said, let's make it a little bit more interesting, and there are some weak points as well. So shared administrator account, no privileged access management, and service principals are actually overprivileged. We have owner and admin service accounts in that company. The CI/CD pipelines, they do exist, but they lack approval gates, and basically whenever you commit to main, it will go straight to production, and there would be no approval gates first to validate that everything that needs to be deployed is going to be deployed. And two more things. Secrets are stored in pipeline variables themselves, so there is no central secret manager in place. And due to some lack of foresight, contractors still can retain access after their project ends, and their credentials are still valid for longer periods than required. And based on what you have seen, which incidents do you think will have the highest probability? Now, while you think about it, I will speed up the recording and we'll jump to ChatGPT app. It is now called ChatGPT, not Codex anymore. And I will run that assessment end to end for this company. So you can read what I'm writing here, hopefully, and we will see the results soon. Okay, and we have the assessment score. The final risk, as you see, is at 20%, with unauthorized access leading the accident scenario at 39%. Well, it kinda makes sense that the unauthorized access can be the issue if you have their contractors and their passwords never expire, their accounts never deleted. So that is very likely to happen at one way or another, and that is their primary weakness, that the shared administrator accounts and no PAM is implemented, and that drives the elevated privilege escalation risk up to 55%, and the credential set to 30%. Production governance is weak as well. Direct commits to main and no production approval gates produce 55% operational risk, error risk. And we have some strong controls as well. So all of the MFA separate admin accounts from regular user accounts, and CI/CD is top notch. Well, almost top notch. So all of that is good. And the additional gap over here is that the secret rotation is inconsistent and secrets may live outside approval secret management service. Well, once again, what we know, and their prioritized actions is to eliminate shared accounts and use those individual entities, implement PIM, or just-in-time privileged access management for Databricks, protect main, and move all of the secrets to a central place to enforce the rotation. And even more, we now can ask what is the business impact of those incidents, and based on my current numbers, the customer impact is 16.6. It is the highest outcome, and it basically means that because of the unauthorized access, we could have exposure of customer data and disruption or to customer-facing services, and that would lead to a loss of trust or complaints and support load. In addition to that, we have a slightly lower regulatory impact. So there is a potential that the privacy reporting obligations compromised, and it is possible that there would be penalties if data is exposed. While the revenue impact is not very likely, or the less likely among those all, because losses from the service disruption and incident response and reduced sales, while possible, maybe not that big of a deal. But that, once again, is based on my numbers and my current model. So what we see in here, it kind of makes sense, I think. Well, at least I would put it in a similar way, mostly because I coded those models and so on. But for me, at least, it makes sense. And this is exactly the kind of reasoning I would expect from a senior security architect. Now let's repeat what I like about this model and this approach. First of all, the consistency. That if I would rerun that whole exercise and give the same numbers or the same answers or similar type of answers that would produce a similar type of input with ones and zeros in right places, I would get exactly the same result. And that consistency is very important for auditability and traceability. Then the next thing that is good is explainability. So every probability that comes from expert knowledge, it can be opened and check what is a risk probability based on input parameters. There are no hidden model weights or just something that comes from a random query over the internet search. Next, the scenario modeling is good, so we can ask what if we introduce PIM, and the model numbers would be changed, and we can experiment with it, and the model will create a new higher likelihood of the incident of different incidents and different business impacts without waiting months for real incidents to happen and see what is going to change. And the last thing, what I added just now, is business language. Managers, they don't care about missing controls. So if you say that I need to implement PAM it would not really hit the target. Whereas if you say that based on a business outcome of a potential to lose revenue or to have a customer impact of 16%, and if implemented, that likelihood to impact the business outcome goes back to 11%, that kind of numbers that people in higher positions usually appreciate. But at the same time, there are some limitations with that model. It's not predicting the future, it's just estimating the likelihood. And if the model says that the likelihood of a business of user impact is 16.6, it doesn't mean that after, I don't know, 5 months, it would be, it would come true. Not necessarily, it's just a chance. What is the probability of the impact to the business outcome? It's just, once again, estimating the likelihood. Those probabilities, that they come from the expert knowledge and not millions of historical incidents. While it is possible to run through millions and millions of those historical records, I haven't done that exercise, and the expert knowledge is limited. Some controls, they can interact in complicated ways that are not captured in the current model, and this current model is still an approximation that I would like to work on more and more. And lastly, this model is designed to support security architects, not to replace them, because people trust balanced evaluations far more than the hype. And it would be good to give another tool to the belt, rather than trying to replace something that works very well. And now, so far, that engine can infer those incidents and business impacts. Next step is making it even more actionable, and instead of simply saying that the customer impact is 65%, 16.6%, I want the engine to explain why, identify the controls that driving those results, and eventually answer the question like, if we only have budget for one security initiative this quarter, which one will reduce the business risk the most? So that kind of thing that I want to achieve. And that's where I think probabilistic reasoning becomes generally useful for security governance.